We want to show that x cubed minus 2x squared plus 0.5 equals 0 can be rearranged to give x equals x cubed plus 0.5 all divided by 2x. So note we're starting with something of the form f of x equals 0 and rearranging it to give x equals g of x. Let's start with the x cubed minus 2x squared plus 0.5 equals 0. If we rearrange this to give x cubed plus 0.5 is 2x squared, and then just change the sides, so we have 2x squared is x cubed plus 0.5, we can note that 2x squared is 2x times x. So if we divide both sides by 2x, the left-hand side just gives us x, and the right-hand side x cubed plus 0.5 divided by 2x as required. We now want to show that x cubed minus 2x squared plus 0.5 equals 0 has a root between 0 and 1. So f of x is equal to x cubed minus 2x squared plus 0.5. F of 0 then is going to be 0, take away 0, plus 0.5, which is 0.5. F of 1 is 1, take away 2, add 0.5, which is minus 0.5. So we have a change of sign, and we know that this implies there is a root in the interval 0, 1. We want to use the iteration formula xn plus 1 is xn cubed plus 0.5 all divided by 2xn. It appears that I've forgotten to put the n on this x, but it should be there. We want to find the root between 0 and 1 using this formula, correct to one decimal place. Let's take x0 equal to 1. So, using our calculator shortcut, put 1 and equals into the calculator. This stores 1 as the last answer. We then need to set up our formula in terms of the last answer. So we'll begin by cubing the last answer and then adding 0.5. This should be in a bracket. We then divide by open bracket 2 times the last answer. So note that the xn's are the last answer in our formula. If we do this, we produce the sequence of values. x0 is 1, x1 is 0.75, x2 is equal to 0.614 and so on. x3 is 0.5956 and so on. And you should be checking on your calculator that you can produce this sequence of values using this calculation. If you continue with this sequence, x10 is 0.596 and so on, and these decimal places have not changed for a few calculations. This suggests that to one decimal place, our answer is 0.6. So to one decimal place our root is 0.6. But we need to check this, remember. If we look at a number line, here's 0.6, 0.55 and 0.65. We choose 0.55 and 0.65 as any number within this range rounds to 0.6 to one decimal place. We need to check that the root is in this interval. Therefore we need to evaluate f of x at each of these points. F of x, remember, is x cubed minus 2x squared plus 0.5. We need to work out f of 0.55 and f of 0.65. If we do this, we find that this value is 0.061 and so on, and this one is minus 0.07 and so on. There is a change of sign, so the root is between 0.55 and 0.65, and therefore the root is 0.6 to one decimal place. It's worth noting that in the last two examples, this one and the one before, we worked with the same equation, x cubed minus 2x squared plus 0.5 equals 0. In the last example, we rearranged to get x was the cube root of 2x squared minus 0.5. In this example, we rearranged to get that x was equal to x cubed plus 0.5 divided by 2x. However, we started both iterations with x0 being equal to 1, but this one found the root in the interval 1 to 2, and this one found the root in the interval 0 to 1. So different rearrangements find different roots. We'll talk more about this later.